Hello, everyone. Good afternoon, one and all present here. Dear authors and invited guests, welcome to technical session 9G. Myself, Harsh Soni, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the fourth World Conference on Information and Systems for Business Management, ISBM 2025, Bangkok, Thailand. The fourth edition of the conference is being organized in a hybrid mode. The physical event was held on 24th of September 2025 and 2025, and the virtual event is being held through Zoom. That means yesterday and today. That means 25th and 26th of September 2025. I hope you will enjoy this last session of this conference. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder so that you can conclude your presentation on given duration. There is another request to all the participants that you may all please stay connected with us till the closing remarks. Further, we also want to give you some publication update at the end of the session. Further, if you have any query or any update, you can directly write it to me in the chat box. I'll be happy to assist you over there. Just before we start the session, I'd like to introduce you all to the chair for the session. Just a second. We have with us Dr. S. Anupama Kumar. Dr. Anupama Kumar is an associate professor at RV College of Engineering, India, with 22 years of teaching experience. Her academic disciplines include computer and society, parallel computing, and data mining. Welcome, ma'am.
Welcome, Harsh. Hello, I'm there.
Yes, ma'am. Yes. Okay, do we have any opening remarks for the participants, ma'am?
All the best, everyone. I think the time limits have been informed already. It's 10 minutes.
Yes,
Wishing
ma'am.
you all the best for the presentation.
Thank you, ma'am. Okay, so now moving for the first presenter we have. First, we have DS Benago, and he's going to present the paper title, A Survey on Image Forgery Detection Techniques Using Error Level Analysis and Convolutional Neural Networks. Is there anyone who's going to present the paper on behalf of him? Okay, I think so. He's not available with us. Is Chetana is available? Okay, Chetana is also not available. I think so Trilok is available here with us.
Yeah, sir. Yeah, I am available.
Yes, so you may please present your paper title, Enhancing Query Understanding Using Deep Contextual Embeddings in Information Retrieval Systems.
Yeah, sir. Can I start my presentation, sir?
Yes, you may please.
I sent request, sir. Accept that one for sharing the screen.
You may please start again. Try again once again.
Enhancing query understanding using deep contextual embeddings in information retrieval systems. The abstract, this work is introduce a framework for query comparison with information retrieval systems using sentence BERT embeddings like bidirectional encoder representation for transformers. And the queries and documents are transformed into a dense semantic vectors and cosine similarity measures relevance. And the introduction is that the traditional information retrieval systems rely on keyword matching, which fails to capture the deeper semantics. User queries expressed via paraphrasing, domain-specific terms, or indirect expressions often lead to poor retrieval accuracy. there is a need for semantic context aware query understanding, like deep contextual embeddings from BERT. Variants capture the fine gradient semantic meaning by transforming text into high dimensional vectors, and it measures a semantic similarity beyond word overlap. The literature survey will it's earlier models like back of words and lexical overlaps ignored the semantic intent. And the recent works to 2020 to 25 showing like advances using BERT-based embeddings, contextual query expansion, transformer frameworks, and hybrid semantic generative approaches. Our study uniquely combines sentence BERT with cosine similarity distributional analysis. This is the architecture of the mainly first one is like data pre-processing. In the data pre-processing, we use already tokenization, lower casing, function removal, stop word removal, stemming, and lemmatization. And next one is future extraction. In the future extraction, contextual embeddings, sentence bit. And after that, uh, semantic similarity. Here again consider like cosine similarity and similarity matrix. And the dimensionality reduction, here UMAP and nonlinear. This ensures both semantic alignment and interpretability. First one is pre-processing. Here we use like tokenization, stop word removal, stemming, and lemmatization. And embedding for using like sentence bed. And the cosine similarity computation for query document pairs. And the outlier detection via IQR, hierarchical clustering for semantic grouping. And the first one is like query document similarity heat map. Here heat map showing like query document similarity 0.3 to 0.8, where the darker shades are indicate the higher relevance. And here histogram is frequency distribution of similarity scores. Here like all query documents Matlow, the fall around 0.6 similarity, and it's showing the moderate alignments. These proves the embeddings capture meaningful relationships. And the next one is KDA plot for query document similarity scores. Here the while concentration around the 0.6. Here this is the most one. And the box plot for document similarities per query. Some documents align strongly with queries, while others remain the irrelevant, improving system transparency. Here, like the clustering. Here, hierarchical clustering group semantically closed queries and documents. And first one is like Python related contents and together, while Java related the items from separate groups. These demonstrate the natural semantic grouping and the supports the better retrieval and recommendation systems. The conclusion is the mainly the framework enhance query understanding by combining deep contextual embeddings with cosine similarity improve the retrieval accuracy. While visualization transparency, these contributes to the explainable AI for semantic search. And the future extensions may explore the adaptive thresholds, domain adaptation, or hybrid generative discriminative approaches. These can expand the applications to open domain question answering, intelligent assistance, and domain specific IR tasks. These are the sample references. Thank you. Any questions?
Uh, can you talk something about the efficiency of the BERT system which you have implemented, Pa?
Ma'am, efficient, it's like bidirectional representation for transformers.
Okay.
Mainly like heavy model. That is like bet base means 110 parameters. And the
Fine.
bet large means 340 parameters, ma'am.
What is the size of your data set in this case?
Ma'am, data set size is, I didn't mention, ma'am. In PPT, I didn't mention. In paper, I mentioned, ma'am. I forgot.
Only if you tell me, that's fine for now.
Hmm.
No problem, no problem, no problem. Don't take tension. Good work.
Okay, ma'am.
Okay, thank you, Trilok. I think so. Once again, your presentation is been scheduled,
Yes, sir, yeah.
right? Okay, just a second. I'll just show the flyer here. Yes. Your next paper title is Evolutionary Multi-Objective Optimization of Neuro-Fuzzy System in Non-Stationary Time Series Forecasting.
Yes.
Okay, you may please proceed.
This evolutionary multi-objective optimization of neurofuzzy systems in non-stationary time series forecasting. This study introduced a neurofuzzy inference system optimized using NSGA2 evolutionary optimization multi-objective algorithm to forecast non-stationary time series. The approach is balanced the predictive accuracy and model compactness by evolving fuzzy rules, membership parameters. Here the experimental results on synthetic data sets showing like reduced residual errors, adaptability to temporal changes, which is like fuzzy surfaces further validate the transparency. The introduction of this like forecasting on non-stationary time series is a challenge as a statistical properties and temporal dynamics shift over time. The traditional models like ARIMA or static deep learning architectures fail to adapt to these changes. The mainly neurofuzzy systems are provided interpretability and adaptability by combining fuzzy logic with neural networks. However, the designing efficient neurofuzzy systems requires optimizing membership functions, rule bases, and consequences of evolutionary multi-objective algorithms like NSGA2 offer a way to handle this trade-off. The literature survey is like the study is like neurofuzzy systems for dynamic forecasting. First one is like in 2022, Lawfer discussed the stability and adaptability in evaluating systems. And the 2023 is highlighted the hybrid architectures on combining memory, fuzzy rules, and evolutionary learning for financial forecasting. And the 2024 reviewed online evaluating fuzzy models for handling non-stationary. And in 2025, applied multi-objective optimization for urban food flood forecasting. Collectively, these work confirm the importance of combining fuzzy systems with evolutionary algorithms to achieve the robustness and interpretability in non-stationary environment. The methodology is like first one is like data pre-processing. Here we preparing the time series data for modeling and the feature selection, choosing like relevant features for modeling. And the third one is like forecasting. Here we predict the future values using the model and the objective function formulation. Define the goals for optimization and the evolutionary optimization. Here we are applying the NSGA2 for optimization and the rule surface visualization. Here rule interactions for interpretability and here model diagnostic. Here we evaluating the model performance and residuals. Here is like first visualization is like prediction errors. Here the cyclic residual oscillations suggesting like systematic biases in temporal model predictions. And the second one is like evolutionary. Here like best RMSE for generations. Yields rapid like descent stabilizing near global minimum. And the conclusion level, this research demonstrates that evolutionary optimization of neurofuzzy systems is an effective strategy of forecasting in non-stationary time series. Here, NSGA2 framework framework ensures the accurate predictions while maintaining the model simplicity and avoiding overfitting and improving like interpretability. And here in the future work is like we can in the dynamic overall this study provides a scalable and and intelligent forecasting in dynamic environments. And the references, thank you.
Once, Trilok.
Yes, ma'am. Yes, ma'am. This one.
Systematic bias and temporal model. Okay. Next slide, please. Minimum you have not taken two different metrics for comparison, or you have taken only
Ma'am, we
two?
took, ma'am, in the PPT, we didn't put, ma'am, we forgot to put. In
Ah,
paper, we
see.
put, and
My
in
dear,
paper, we.
these are certain critical points which you should not miss in the PPT. Okay.
Yeah, yeah, ma'am. That's
Otherwise,
what.
your
That's
results.
what.
Can you go to your conclusion, please?
Yeah, ma'am.
See, so only yes, your conclusion gives me that approach, and that is not found in the PPT. Hmm?
Yeah, yeah.
Okay, okay, Trilok.
Okay, ma'am.
Thank you, Trilok. Now I'd like to invite the next presenter. Next, we have Ritu Raut. Is Ritu is available? Is anyone is presenting on behalf of her? Okay, so I think so. DS Panagua is not available as well. Again, Trilok is your turn. I'm just sharing this. Yes. Trilok, your next paper title is Fuzzy Neural Hybrid Models for Early Detection of Neurodegenerative Disorders using Multimodal Medical Data and Temporal Pattern Analysis.
Yes, sir.
Are you ready?
Yeah, yeah, sir. I'm ready. I'm sharing the screen.
Okay, yeah.
This fuzzy neural hybrid models for early detection of neurodegenerative disorders using multimodal medical data and temporal pattern analysis. Here we proposed a fuzzy neural model that combines fuzzy logic for interpretability with LSTM networks for temporal pattern analysis. Here we are using multimodal medical data that the system achieves the highly accurate early detection of neurodegenerative disorders while providing transparent insights into disease progression. Now here like neurodegenerative disorders such as Alzheimer's and Parkinson's are increasing worldwide. And the early detection is critical but difficult due to the subtle, heterogeneous, and time-dependent symptoms. Advances in multimodal data open opportunities for intelligent diagnostic systems. Traditional diagnostic methods struggle with uncertainty, non-linearity, and incomplete data. Here, we existing AI models often use static or unimodal inputs, missing the temporal and cross-modal interactions crucial for understanding disease progression. Here, like as here, Perrier, we fuzzy logic for our neural networks individually shows that strength but have the limitations. Most lack of temporal modeling and multimodal fusion. Few studies integrated with fuzzy rules with deep learning for neurodegenerative diagnostics. Here the proposed methodology. We proposed a hybrid fuzzy neural model for fuzzy logic, encodes features with Gaussian membership functions, providing interpretability, and LSTM networks. It captures the temporal progression patterns, and the fusion of multimodal data enables robust classification. Here, like a first input data. In input data, we took patients and the time steps and the future vectors. And the next one, feature selection. Here, mutual information. Here, like correlation based criteria and the classification layer. In the classification layer, sigmoid layer, and trainable parameters. And the loss functions. Here, loss functions is like binary cross entropy and gradient descent. And the optimization, convergence analysis. Here, learning rate, convergence criteria, and trainable parameters. Here, in data pre-processing, we use like mean and standard deviation. And the temporal modeling with LSTM. Here, hidden states and cell states. And the fuzzy memberships. Here, Gaussian membership function, fuzzy rule index. Here, the algorithm workflow. Step 1 is normalizing the features. Step 2, selecting the top K informative features. In the step 3, we are applying the fuzzy membership functions. And step 4, feed fuzzy sequence into the LSTM. In the step 5, we predict in the class or healthy or decline. In the step 6, training with cross entropy loss and convergence checks. Here, first one is like classification. Confusion matrix shown perfect separation between healthy and decline groups. No false positives or false negatives. Strong evidence for models in binary classification task. Here, we took the multimodal feature evaluation over time. Here, the feature evaluation across time shows heterogeneous progression patterns. And this is like temporal feature dynamics. And the LSTM, here we use like healthy or decline. Here, correlation heat maps and here like correlation heat maps. First one is, first heat map is showing fuzzy future correlation like healthy. And the second one is decline. Here 3D PCA trajectories for patient features over time. Patient 0 to 5, total it's like 6 in the disease progression patient paths. And the correlation heat maps like dependencies like strongly between the groups. And the conclusion is like approach successfully integrates uncertainty handling with temporal modeling. It achieves accurate, interpretable, and clinically relevant predictions. Future work is like apply to real-world data sets, extend to multi-class disorders, and enhance personalized decision supports. Like references. Thank you.
What are the various parameters on which you can check it?
Ma'am, whereas here we check it like as Alzheimer's disease and Parkinson's, ma'am. Mainly we use it these two only in the with the early data because it's increasing worldwide. In the various yes, ma'am.
Okay. What is the size of your data set? From where did you collect the data?
Ma'am, here we collected from Kaggle, ma'am. It's like it
Size
is
of
like
the data.
synthetic size of the data. It is medium data. It's not big and small also. It's like
Okay.
10 columns, ma'am.
If it is a small data set, do you think your results will be perfectly coming?
Yeah, ma'am. Yeah,
Finding
it's
of
perfectly
accuracy?
coming. Yeah, yeah.
Okay. Okay.
Okay, ma'am.
Okay. Thank you, Trilok. Questions are there. Yes. Thank you, Trilok, for your wonderful presentation. Now next we have Arun-Shri Banowati, and she is going to present the paper titled Green Digital School Management as Technology-Driven Strategies for Achieving Sustainable and Eco-Friendly School Governance. Dear presenter, you may please proceed with your presentation.
Yes. Green Digital School Management, GDSM, a model integrating digital technologies with environmental responsibility for sustainable school governance. A systematic literature review, SLR, of
Dear,
87
please proceed with
high-quality
your
studies
presentation.
revealed GDSM components components like digital environmental policies, IoT-based monitoring, and participatory platforms.
Ma'am, are you
Challenges-
able to hear the presenter voice?
Explores Green Digital School Management, GDSM, a model integrating digital technologies with environmental responsibility for sustainable school governance. A
Dear
systematic
presenter, your
literature
voice is
review
not audible to us.
high-quality studies revealed GDSM components like digital environmental policies, IoT-based
Is there
monitoring,
anyone who is
and
able to
participatory
like
challenges include
hear the voice of?
Is it a recorded PPT, your presentation you're trying to show us?
Hey, please do one thing. You can solve the technical issue with your mic, right? Till then, we are going to consider the next presenter. Hope this will be fine. Yeah. Thank you. Okay, so next we have Tsunenori Inakura, and he's going to present the paper titled New Method to Construct a Database and Design a Business Process from Institutional Document Using Generative AI.
Oh, I'm Inakura from Institute of Science, Tokyo. Today, I will talk on new method. Sorry, new method to construct a database and design a business process from institutional document using a generative AI. So the time is limited, so today I talk on only the essence of this new method. Okay, the institutional research in university relies on a data warehouse built from many operational databases across the departments. These databases are independently designed and frequently customized, so data rotation and meanings are unclear. Also, during the data migration, data consistency sometimes breaks. It's reduced trust in the analysis. One of the answers is a categorical database. A categorical database ensures that the data reference stay consistent across migrations and updates. Or rows, which is one of the categorical database, describes the database schemas in natural language, making structures easier to read for non-experts. But there are the problems. In practice, as many relationships must be written as natural language sentence, so it's very troublesome. And the data and the business process are coupled unavoidably. So without modeling the process, it is still hard to know which. Sorry? No problem? Okay.
Yeah, you're
Yeah,
audible,
okay.
no problem. You're audible.
Okay, it is still hard to know which task produce which data and who owns it. So our response is the leveraging generative AI. We construct rows and design EPCs from the same institutional documents. So the cross-check all rows and EPCs to improve the consistency and obtain a unified view of the data and process AI. Let us introduce to the categorical database shortly. The database constructed based on the categorical theory principle is a categorical database. This is a schematic figure of the database schema, and the categorical theory principle for the database follows. There exist tables, there exist foreign keys connecting tables. For every table, there exists primary keys. Any sequence of foreign keys can be represented as a single composite foreign key. All foreign keys are functional. This is a condition. The database satisfies this condition is a categorical database. And in the categorical database, the ensure data migration, integrity for the data migration. So in the data migration is equivalent to the redesigning the database to the smaller one. Here it is for the data warehouse, with keeping the data reference accurate. So in the particular database, data integrity is automatically ensured. So the particular database is powerful tool for to treating the database. And the overall, this it is an ontology log. Overall describes the concept and relations with natural language. This is an example of the categorical database, and this is an example of overall. These are essentially the same. In overall, the relation between the tables or concepts described in natural language. For example, the relation between the graduate and student is described as a grade is awarded to the students. So we can easily understand the meaning of the foreign key or the relation with these concepts. So all relations are described in the sentence in orals, but which means that the all relations must be converted into the predicates. So it's very troublesome. So we leverage generative AI still in dealing with the natural language. So what we want to do is to construct categorical database with generative AI from institutional documents. We use the institutional document as a source because the institutional documents are robust rule sources and align well with generative AI. So we provide the institutional document to generative AI such as the ChatGPT, and with help of the ChatGPT construction or categorical database, it is what we want to do. The first step is the preparations. We provide the papers on the categorical database and overall these papers, and request ChatGPT to explain the details of these contents. This is just the installation of knowledge of the categorical database to ChatGPT. The second step is extracting the concept. We provide the institutional document to ChatGPT, and we ask ChatGPT to extract concept from the institutional documents, which should appear in the operational databases. Then ChatGPT provides these concepts of the tables, so it's good. It's good. That's the second step. The third step is extracting the relations. We also ask to extract the relations between the concepts from the institutional documents and express them in a simple and natural sentence. So ChatGPT provides some candidate to the sentence. For example, the relation between the grade and student is the number one, grade is awarded to student. Number two, grade is given to student. Number three, grade is received by student, and so on. So there are some candidates to explain the relation between the concepts. So we pick up so one of them. So we, in this case, so yeah, that's good. Number one sounds good, and so on. And the best sentence is strongly dependent on the database designers who knows the detail in the institutional documents. So human review is needed in this stage. So we pick up one of them, the relations. So repeating this process to all relations, we obtain the state of the oral database. This is almost finished of the construction database, but not finished. In order to completely construct the categorical database, one more step is needed, but we skip it because this state is almost the final version. Okay, the next is we move to the business process, event-driven process chain, EPC. What is the EPC? EPC is a diagram for business flow, and it shows when sometimes happens and what we do. So event induce the function, and function results some events. Events induce some function. Again, this making the result. So event and function must go in turn. Alternates is the EPC. And input data and output data also shown for each function, input data and output data. So this using this EPC, we can see which task makes which data. So input data and output data consist to the to know that the which task makes which data. So again, first we install the noise EPC to the ChatGPT, and we provide the instrument document, the same document to ChatGPT, and we ask extract EPC from the document. So ChatGPT gives us to this EPC business process. So we construct a database and we design a business process EPC from the same instrument document. So essentially, these are consistent with each other. So cross-check then gives dual consistency and the clear map of the data rotation, data creation, and ownerships. So let us summarize. We show a new way to construct a database and design a business process from same instrument documents, leveraging generative AI. We construct an overall database to describe the data relations. Also, we design an EPC to show business process. Generative AI helps read the documents and draft both of orals and EPC, although human review is still needed. We compare the oral and the EPC, and we can fix the mismatches. As a result, we see where data is, how it is created, and who is responsible. That's all. Thank you. That's all.
Okay, thank you, dear presenter.
You are you're comparing OLAG and EPC to fix the mismatches. And what you're comparing it?
Okay, in this case, we cannot find the mismatches between the OLAG and EPC, so we can check the mismatch, but in this case, we do not fix
each event has a different state of working. No,
sorry?
Each event, it has a different state of working here, right? So how do you compare those events for...
Okay, in principle, the functional, each function in EPC corresponds to the relations, something like that. What is the data and the correspond to the concept in org and so on. So we can compare the EPC and org, whether it is consistent or not. And if there is, we can find the mismatch.
Okay, thank you.
Okay, thank you, dear presenter, for your wonderful presentation. Now, again, I request Arum if she is able to present the paper. She may please proceed.
Yes.
Yeah.
As technology-driven strategies for achieving sustainable and eco-friendly school government. Abstract. The study explores Green Digital School Management (GDSM), a model integrating digital technology with environmental responsibility for sustainable school governance. A systematic literature review of 87 high-quality studies revealed GDSM components like digital environmental policies, risk monitoring, and participation platform. Challenges include infrastructure gap and limited digital environmental literacy. Innovative strategies such as digital teacher training, cross-sector partnership, and gamified environmental education tools are emerging. This review contributes to GDSM conceptual development and offers recommendations for policymakers, educators, and technology providers to build smart, green, and sustainable school ecosystem. Next, introducing GDSM. The escalating issues of climate change, environmental degradation, and resource exploitation positive education as a key sector for sustainable development. Schools are evolving beyond knowledge transfer to become agents of social and ecological change, leading to the rise of GSBM and GSBM emphasizing environmental sustainable governance, including efficient energy or water use, responsible waste management, and a culture of sustainable. GDSM core components and principles. GDSM combines environmentally efficient school governance with great strategies digital technology use. Key indicators include digital-based environmental policy, integrated digital monitoring system for resource, electricity, water, paper, and digital learning facilities promoting sustainable. Next, change of GDSM implementation in the context in primary education. 1. Infrastructure gaps, limited internet, hardware, and technical support, explicit in rural areas, rate and imbalance in GDSM implementation. And 2. Low digital and environmental literacy, educator and familiarity with digital platform and sustainable practicability hinder adaptation. 3. Resistance to change. Fear of technology complexity, increased workload, and viewing environmental issues and external responsible. And 4. Policy fragmentation. Lack of integration between education, environment, and IT sector, hindering synergistic implementation. And next, strategy-based participatory form or GDSM. And 1. Community-based monitoring. Mobile apps and web dashboard track energy, waste, and water, increasing awareness and participation. And 2. Teacher training, hyper-training, exchanging environmental and technological literacy, enabling eco-pedagogical learning activity. And 3. Cross-sector partnership, collaboration with state institutions and private sector provide technology support and funding. And discussion GDSM as an evolutionary. GDSM is an evolutionary model of sustainable school management driven by digital technology, exchanging efficiency and accountability. It redefines education role in creating eco-friendly, collaborative, and adaptive learning ecosystem. Technology as a key lever for community participation and data-driven, transparent governance. An environmental sensor and digital reporting platform boost accountability and real-time monitoring. And last conclusion, GDSM transparency, resource efficiency, teamwork, and environmental responsibility. Key challenges include influencing digital infrastructure, low digital and environmental literacy, and a lack of technology and sustainable focused education strategies. Future research should conduct stock field studies to the GTSM implementation in real context, especially in digital limited areas, and developing conceptual model adjustment to local cultural and geographical characteristics and exploring cross-sectoral and actor involvement are promising research direction. Thank you.
Good presentation, Aramsri.
Thank you, Mom.
Good presentation. You have explored. Can I know where is your experiment conducted?
Wait, Mom.
Your data for this entire work. Have you focused your education work only in a specific area or something? Because you have quoted on less digitalized areas, right? So where did you focus on? Your people for research. That's my focus of question.
Yes. My focus challenge include infrastructure gaps and limited digital environmental literacy.
Okay. Fine. Thank you. You can proceed with it. Good work.
Thank you, Mom.
Arshi, you are not audible.
I'm so sorry. Okay, so now as we have completed all the
Image forgery detection anta.
hello.
Une ma'am nodi. A survey on image forgery detection techniques using CNN. IIM, some Indian country, Indian place only, Bhutan or something. Asian country, I mean.
Hello. Hello.
Yeah, you are audible. I'm able to hear you.
Okay. 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 So now we have completed the presentation who are present here in the session. Now I'm just announcing those people name who are not presented the paper and they are not able to attend the meeting. Just a second. Yes. First, we have DS Vanagao. And okay, is there anyone who's going to present the paper on behalf of him? Okay. Chetna RM. Ritu Raut. Again, DS Vanagao. Vijaya Siva. So these participants are absent in this session. So move for the closing remarks of the session. Okay. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough to all the participants. We, on behalf of whole team, thank you for your support during this fourth version of the conference and all previous three versions of this conference. We will be happy to have you all in the fifth version in 2026. Further, all the presenters would be getting their digital certificates through email within 2 to 3 working days. And the publication will be live within 7 to 8 months. So kindly cooperate with the team ISBM 2025. Now, I also want to thank our session chair for being a chair of the for chairing the session. And ma'am, there is one token of appreciation to be a chair on behalf of Global Knowledge Research Foundation and Team ISBM 2025.
I think this is the certificate for.
Oh, so sorry.
That's
Okay.
fine.
This is a certificate for you, ma'am.
Thank you so much.
Okay. Thank you, ma'am, for your valuable presence. Once again, thank you.
Thank you.
Now I request all the participants that you may please like turn on your camera so we can capture the good memories of this virtual conference. To all the participants, if it is possible, you may please turn on your camera. Okay, just a second, once again. Yeah, thank you so much. Thank you for your valuable presence, ma'am. And thank you all the
Thank you.
participants
Thank
for
you.
their wonderful presentation.
Thank you.
Thank you,
I'll
ma'am.
be porting my PPT to the email ID which you have given me.
Yes, ma'am. You can share it.
Okay.
Yeah.
Thank you. Thank you, Harsh. Thank you.